Welcome to Noble of Academy. My name is Dennis Uvongi. Today we shall be revising questions on melting point. Our first question goes like this. Why does silicon have a higher melting point than sulfur? If you're first time to come to this channel, make sure you subscribe and click on the notification bell. Why does silicon have a higher melting point than sulfur? First of all, you have to look at the bonding in silicon. How is the bonding in silicon, and then how is the bonding in sulfur? So, silicon compared with the sulfur, both have covalent bonds, but the bonding in silicon is greater than the one in sulfur. So, the atoms of silicon, they bond through strong covalent bonds, forming giant covalent structure. So, in silicon we have silicon has giant covalent structure in its molecule. Whereby each silicon atom is strongly bonded through a covalent bond to other silicon atoms. Whereas in sulfur, in a molecule of sulfur, the molecules are held by weak instantaneous induced dipole, instantaneous induced dipole forces of attraction, the ones which are weak. Whereas here, the molecules are held by strong covalent bond. That is in silicon. So you find all the atoms are held by strong covalent bonds, forming a giant covalent structure. This one makes silicon to have a higher melting point than sulfur. So, we can go to the second question. Why does sulfur have a higher melting point than chlorine? You're going to look at the two atoms. When you look at a molecule of sulfur, in a molecule of sulfur, we write it as S8. And then a molecule of chlorine, we write as Cl2. That's the molecule of chlorine. So here you can see that we have eight atoms in a molecule of sulfur, whereas in chlorine we have 2 atoms in a molecule of chlorine. So here we have what? Here we have more electrons. Then here we have few electrons. So it means here we have a greater induced, actually we have a greater instantaneous induced dipole forces of attraction. Forces of attraction. These are the forces that hold the atoms within the molecule together, and these forces are greater in sulfur because in a molecule of sulfur there are more electrons compared to the molecule of chlorine. So the forces, the instantaneous dipole-induced dipole forces of attraction would be greater in sulfur compared to the forces in chlorine. It is still the same forces that contributes to the strength of the van der Waals forces of attraction. So we have here increased van der Waals. Increased van der Waals forces of attraction. So, the greater the instantaneous induced dipole forces of attraction, the greater the van der Waals forces of attraction. So we have here also increased van der Waals forces of attraction in sulfur compared to chlorine. So this one here explains the reason as to why sulfur has a higher melting point than chlorine. So we can go and check on C, part of the question. So, in C, explain why the melting point of silicon is much greater than that of phosphorus. It will still take us to the bonding. Look at bonding in silicon, and then bonding in phosphorus. In silicon, the atoms are held through strong covalent bonds forming giant covalent structure. Whereas in phosphorus, we have the molecule of phosphorus as P4. Meaning in a molecule of phosphorus, we have 4 atoms held together. And the atoms are held together by weak instantaneous induced dipole forces of attraction. So the forces holding the molecules together, they are weak. That is in phosphorus. Then in silicon, we have the atoms held through strong covalent bonds forming giant covalent structures. So if you are to explain why the melting point of silicon is greater than that of phosphorus, look at the bonding. So you just say a molecule, the atoms in a molecule of silicon is held by strong covalent bonds forming giant covalent structure. Whereas in phosphorus, we have weak forces of attraction. So that is the instantaneous induced dipole forces of attraction. So going next to our last question, we are looking at melting point of aluminium being greater than that of sodium. So if you look at aluminium and then sodium. Aluminium and sodium, all of them, they have metallic bonding, or we can just say metallic bonds. So even here we have metallic bonds. But now what determines the strength of the metallic bonds here? It is the number of electrons that each of the atoms contribute to the sea of the localized electrons. So aluminium contributes 3 electrons, and then sodium contributes 1 electron. Each atom contributes 1 electron. This is to what? This is to C of the localized electrons. To C of the localized electrons. And also in aluminium, the atoms, after donating electrons, will now have Al3+. Then in sodium, we shall have Na+. So you check the pluses too. 3 positive, 3 pluses here. That is this is a proton, and then actually this one here is a cation, and this one here is anion. The number of positive charges that each have will also contribute to the strength of the metallic bond. Aluminium has 3 plus, sodium has 1 plus. And then the electrons that are donated, 3 electrons and then 1 electron. So aluminium has a stronger electrostatic forces of attraction compared to sodium, which has 1 plus and then donating 1 electron to the seed of delocalized electrons. So this one here summarizes our revision as far as melting point is concerned. Thank you for watching, and make sure you like the video, comment, subscribe, share. We catch up in our next video.